Ugh.
Good morning, guys.
Morning.
Good morning.
Good morning.
I come into existence. Ugh.
Hey, Luke, you're awake today.
Yeah.
All right, Luke. Sokotoa.
Yeah.
Oh,
I asked
Right?
I asked my sisters if they remembered it, and
Uh-huh.
Joanna's response was, "Oh, I remember that. Good luck, Luke."
Yeah. Okay. Well, that's what you guys had to work on last night was the sine, cosine, and tangents. You started on page 601, numbers 1 through 7. Okay, let's get that out and take a look. Number 1. Okay, are we all at the right spot? I'll give you a minute to get there. 601.
All right.
All right. Okay, they show us a right triangle, and they ask for the sine of angle A. Aristotle, what did you get for that?
16
They
over
went
20.
Oh, go ahead.
16 over 20.
Mm-hmm. And then did you put it as a decimal also to the nearest hundredth?
Yeah, 0.8.
Good. Okay, number 2, Brian, tangent of C.
I said 16 over 20 and 0.8 again.
Tangent is opposite over adjacent, so we don't want the hypotenuse at all.
Okay, then. Let me look at it.
Okay.
C. So that would be 12 over 16.
Yep. 12 over 16, which is 0.75.
Okay.
All right, number 3, Colby, cosine A.
Oh, I have. Why can't I read that? Oh, 6. I have 16 over 20.
That would be sine of A, opposite over hypotenuse.
Oh, no. 12
Cosine
over
is
20.
Yep, 12 over 20. Did you turn that into a decimal?
Yeah. And I got
Which is-
0.6.
Good. Okay, number 4, Grace, tangent A.
16 over 12.
Good. Did you turn that into a decimal?
Yeah, 1.3.
Yeah. Then when did you go the hundredths? So approximately 1.33.
Okay.
Okay. Number 5, Lily. That's cosine C.
16 over 20.
Good. And as a decimal?
16. 0.8.
Good. And Luke, number 6, sine C.
12 over 20, which is 0.6.
Good. Okay. Number 7 said use a special right triangle to express the sine of 60 degrees as a fraction and a decimal to the nearest hundredth. And we didn't really talk about example 2. That went with example 2. We didn't really talk about that.
Yeah, that didn't make sense
Just
because I didn't know which triangle to use. It just said use a special right
all right.
triangle.
So yeah, we'll hang on to that until after we look at the example today. Okay, let's go ahead and look at numbers 16 to 21. Okay. Find sine J, cosine J, tangent J, sine L, cosine L, tangent L. Express each as a fraction and a decimal to the nearest hundredth. Lots of work. Okay. Number 16, let's go back to Aristotle.
All right, so J, the sine is 30 over 34.
Mm-hmm.
cosine is 16 over 34, and the tangent is 30 over 16.
Yes.
And then for L, it's 16 over 34.
Mm-hmm.
Cosine is 30 over 34, and tangent is 60 over 30.
Good. And I'm going to assume that you guys can do, because you did it in the first part, do the decimals, and you don't have to tell me what the decimal part was for that. And those were good, Aristotle. All right, number 17, Ryan.
So we don't have to list the decimals.
No, just give me your fraction.
56 over 65.
Mm-hmm.
33 over 65. 56 over 33.
Mm-hmm.
I have 33 over 65, 56 over 65, and 33 over 56.
Good. All right, 18, Colby.
I have 4 over 5, and
Mm-hmm.
then I have 3 over 5,
Mm-hmm.
and then I have 5 over 4, and then
Hang on a second. Hang on
here, wait,
for that one. That one would be
4 over 3.
4 over 3. Good. That's tangent of L. Okay.
So then I need
Sorry. So now you're on sine L.
sine L would be 3 over 5.
Mm-hmm. Cosine L.
That would be the 4 over 5.
Mm-hmm. And tangent L.
That would be 3 over 4.
That's it. Good. And the next one goes to Grace, number 19. Let's do sine J.
I got 84 over 85.
Good. Cosine.
13 over 85.
Mm-hmm.
84 over 13.
Mm-hmm.
And then for L, I had 13 over 85.
Mm-hmm.
84 over 85.
Good.
And 13 over 84.
That's it. All right. You guys are doing well. Okay, 2 more. We've got some roots here. Lily, number 20.
2 root 5 over 5.
Mm-hmm.
Root 5 over 5.
Mm-hmm.
2
Good.
root 5 over 5.
Mm-hmm.
2 root 5 over 5. And then 1/2.
Excellent. Did you guys have questions on any of those? Because there was some radicals in there that might be confusing.
Yeah, I think I got those wrong.
Yeah, me too.
So for instance, let's do the last part of that one, okay? Lily said 2. Or no, she said 1/2, sorry. She said 1/2, and she's correct. And you might be like, how in the world did she get 1/2? So let's just look at number 20, and we're going to do the last part. So tangent L. So tangent is opposite over adjacent, right? Okay. So Lily, did you do 2 root 3 over 2 root 15?
Yeah.
Okay.
Oh.
And okay, then you can cross out your 2's, right?
Mm-hmm.
All right. So now I just have root 3 over root 15. But Lily was like, I'm not allowed to have that radical in the denominator.
Okay.
Did anybody leave it like this?
Wait, is that one for the tangent L?
Yeah.
For the hypotenuse isn't in.
Oh, you're right.
That's
Sorry. Thank you, Luke. I was looking at the wrong thing for the hypotenuse. Sorry. Okay, let me do it again. Okay, 2 root 3 over 4 root 3. Okay, thanks, Luke. Okay, 2 root 3 over 4 root 3. The root 3's cancel out. And then it just equals 1/2.
Okay.
That actually makes it a lot easier. Okay. All right, 21, Luke.
Okay, so I don't think I did some of them right.
Okay.
But yeah, so 2 root 6 over 4 root 2.
This is for sine of J. Okay, tell me what you had again.
2 root 6 over 4 root 2.
Okay. So that's not necessarily wrong, but it's
You
not,
can't-
keep your answer like that because you can't have the radical in the bottom. So just take that further, Luke. So first you can reduce your 2 and your 4, right?
Oh, so would it be root 3 over 2?
Yeah. Okay, so that's root 6 over 2 root 2. And then, yes, you can divide. Root 6 divided by root 2 is root 3. So root 3 over 2. Good. All right, now cosine J.
1/2.
Yes.
And then the tangent is root 3
Yes.
over, yeah. Isn't it just
Root
root 3?
Yes.
And then sine L is 1/2.
Yeah.
The cosine is root 3 over 2.
Yeah.
And then the tangent is wait. No, wait, because you can't have that in the bottom, so then would it be, yeah, I don't know.
Okay. So for the tangent,
Yeah,
all right. So for tangent L, you had root 2 or 2 root 2 over 2 root 6.
yeah,
Okay. And you crossed out your 2's.
yeah,
And then you had 1 over root 3.
yeah.
Okay. So you can't have the root. So just rationalize that. Multiply it by root 3 over root 3.
Oh, so it's root 3 over 3.
Yeah. All right. There's all of them. Okay. All right. You guys did a good job with that. Like I said, and this is something that you're going to use in Trig pre-calc. So a lot of things in geometry, it's not like algebra where you're going to be using it all the time, but this is something you'll use again. Okay. Let's look on page 597 at example 2, because that's talks about the special triangle. So that would be like that number 7. Okay. It says use a special right triangle to express the tangent of 30 degrees as a fraction and as a decimal. Okay. So if we're going to use a special right triangle and we have 30 degrees, that's a 30, 60, 90. Right? Draw and label the side lengths. X is the shorter leg. And then we're just going to use those properties of a 30, 60, 90. All right. The longer leg is shorter leg times root 3. And the hypotenuse is twice the shorter leg, so it's 2x. Okay. So if we want to express the tangent of 30 degrees as a fraction, tangent of 30 degrees is opposite over adjacent, which is x over x root 3, which is 1 over root 3 or root 3 over 3. Okay, kind of like the one Luke just did. Okay. Let's look at number 2, the practice one for us. Use a special right triangle to express the cosine of 45 degrees as a fraction and as a decimal to the nearest hundredth. Okay, so draw a 45, 45, 90. Okay, and if your legs, they're both going to be the same. If your legs are x, what's the hypotenuse? What's the rule for 45, 45, 90? Hypotenuse equals leg times. Lily, do you remember?
No, I have to look quick.
Okay.
Which one am I looking? Just
A 45, 45, 90. So the hypotenuse is leg times what? It's probably back on page 586.
okay. Leg times
Root 2.
Yeah, leg times root 2. So you're going to draw yourself a triangle, 45, 45, 90. We'll call the legs x. They're the same. And then Lily said our hypotenuse is x root 2. Okay. So they say use a special right triangle to express the cosine of 45 degrees as a fraction and a decimal. Okay, cosine. Cosine is adjacent over hypotenuse. X over x root 2. Okay, just so happens your opposite and your adjacent are the same in a 45, 45, 90. You can cross out your x's. 1 over root 2. Can't leave it like that. Have to rationalize it. Multiply it by root 2 over root 2. And you get root 2 over 2. And they want you to express that also as a decimal. So go ahead and use a calculator for that and do root 2 divided by 2. If you don't have a calculator handy, you can always pop it into your Chromebook. Just Google calculator and pull one up. All right. I like to use the one on my phone. Okay, square root of 2 divided by 2 to the nearest hundredth. Brian, what did you get?
0.71.
Good. 0.71. Okay. I'm going to give you guys another one to try. Use a special right triangle to express the cosine of 60 degrees as a fraction and a decimal to the nearest hundredth. Cosine of 60. Right? So you're going to draw a triangle, which is going to be a 30, 60, 90. Okay. All right, we're going to make x the shorter leg, longer leg 2x. Hypotenuse is x root 3. All right, I want you guys to find the cosine of 60 degrees.
Wait, what? What do all the sides equal?
Make your short leg x.
Okay.
Right? That means your longer leg, I wrote that wrong. Your longer leg is x root 3. And your hypotenuse is 2x.
Okay.
All right, I had to change mine up. Okay, and you're doing cosine of 60. Okay, cosine of 60. So cosine is adjacent over hypotenuse.
X over 2 or 3.
All right, and Grace, what did you get?
Root 3 over 3. No.
What did you use for your adjacent?
X. Oh,
Okay, that's good. And your hypotenuse, I had written it incorrectly the first time and then changed it. Your hypotenuse is 2x.
oh, well, okay.
All right. So we'll end up getting 1/2 or 0.5.
Yeah.
All right. Let's try that number 7 that you guys had for homework and was like, wait a minute, we didn't talk about that. All right, so let's go to page 601, number 7. Use a special right triangle to express sine of 60 degrees. So you could use the same. You want short leg is x, right? Hypotenuse. Fill that in. Okay. And we're doing sine of 60. All right, Aristotle, did you get your answer yet?
No.
Okay, take your time, guys. You can use the same triangle again, though. The 30, 60, 90 is always going to look like that. Short leg, x, long leg, x root 3. Hypotenuse, 2x.
I don't think that.
Okay.
I get 0.9.
0.9. Oh, if you round it to the nearest tenth. Yep. What did you get as the fraction?
Root 3 over 2.
Yep. Root 3 over 2. And then it's a fraction at 0.87 to the nearest hundredth. Okay. 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 Let's also look at page 598, real world example 3. Okay, hiking. All right, so Brian, you're out hiking and you notice a certain part of the trail slopes upward at about a 5-degree angle. And after traveling a horizontal distance of 100 feet along this part of the trail, what would be the change in your vertical position? Like what distance has the hiker traveled along the path? They drew a little diagram there to see that. You see the 5-degree angle.
Wait, what page?
100 feet along the path.
Wait, what page?
This is page 598, example 3. All right, so it says let the measure of angle A equal 5 degrees. The vertical change is x. The measure of the leg opposite the angle. Horizontal distance is 100. Okay, you can see the hypotenuse is y. So you could figure out what that length is by saying the tangent of A is opposite over adjacent. When we're going to change A to 5 degrees. Opposite side is x. Adjacent side is 100. All right, and this is just, they're doing 100 times tangent of 5 equals x. That's just cross products, right? All that they're doing for that is they set it up and then they said, it looks like this. Tangent of 5 degrees, there's really like a 1 over that, equals x over 100. So they're just going to do cross products then. And they're going to say 100 times tangent of 5 degrees equals x. See how it says
Now, how do we know that?
Say that again, Aristotle.
How do we know that the tangent of 5 degrees equals x?
Because we use the tangent, which is opposite over adjacent, and then we made a triangle. You have to look at the diagram. So we looked at the diagram, and it's x. We don't know what it is. We're just calling it x. And then we know that it's 100 feet. We know that they're going to walk, and we're trying to find what x equals. So we could say the tangent of 5 degrees equals x over 100. Right, and then we're going to use cross products to find x. You have to use a calculator. See how it says use a calculator? All right, so on a calculator, you're going to have to type in 100 and then hit tangent button. And then 5 and enter, and you should get 8.74. So try that on a calculator. You have to kind of have the calculator with the tangent button and everything. I always use my phone, and then I turn it sideways so I get the tangent. But you can pull one up on your Chromebook if you want to. All right, you're going to type in 100. On my calculator, I'm going to hit 100 times, and then I'm going to hit the 5 button and then the tangent button. I think.
It doesn't work on mine.
Yeah, mine's giving me
3.3.
I got the one.
mine's giving me a negative, and I'm wondering why. And it's because the calculator is in radians. You have to make sure your calculator is in degrees. On mine, there's like a little button down here that has radians. I'm hitting it to degrees. All right, so now I'm in degrees. I'm going to type in 100 times 5, hit the tangent button, and then I get the 8.74.
Mm-hmm.
So you have to get used to using your calculator.
Yeah.
All right. If anybody else has an iPhone to use, I can show you how to use the buttons because that's what I use. If you're doing it on the calculator on your Chromebook, just make sure you're in degrees, not radians. And I'm only going to give you a couple of those to do. All right. I want you to practice.
I understand how it works, but why do we use the tangent? How do we look at that and say, oh, we just used the tangent? How does that give us the answer?
Because we know that tangent is opposite over adjacent, and we're trying to find the opposite. And we know the adjacent, and we know the angle is 5 degrees. So now we can find that opposite side because we know the angle. Okay. So we can find opposite. If we know an angle and we know like adjacent, then we can find opposite.
Mm-hmm.
We can find hypotenuse also, which they do below that. I'm just going to have you guys try 3A and 3B for that. So 598. I just want you to try those two because you'll do that more in Trig. And then I want you to do, we did number 7. 22 to 27, 602. So there's like 6 problems there.
Are those the ones using the calculator?
Yeah.
So 598.
Yeah, 22 to 27, Luke, just using the they're the ones using the special right triangles. It's like it's
okay.
Too. It's not using the tangent button or anything. It's just the only way you would need the calculator is to turn it into the decimal.
What's the page for
Okay.
the 22 to 27?
602. Okay. All right, I'll let you guys go to your next class. Have a good day.
All right, see you later. Thank you too.
Bye.
Thank you, Mrs. Palmer.
You're welcome. Have a great day, guys.